Welcome to Almost Here, Round the Corner of Future Technology podcast with Richard Jacobs. Future technologies poised to transform our lives for better or worse are the focus of this podcast. Almost here means these technologies are now here and starting to be used, or just around the corner, from Bitcoin to artificial intelligence, 3D printing, blockchain, virtual reality, and more.
Hi, this is Richard Jacobs with Future Tech Podcast. Almost here, round the corner technology. And today I have Trent McConaghy from BigchainDB.com. He's the CTO and co-founder. Trent, how you doing?
Very well. Thanks for having me.
Yeah. All right. Can you tell listeners what does BigchainDB do in the blockchain world? What are you guys about?
Sure. So overall, we see that in the blockchain world, there has been challenges with scale and also with, are blockchains a database, yes or no, et cetera. And given this long history of databases going back decades and decades, where they have really great performance and scalability, creatability, all this sort of thing, we said, why not merge the best of both worlds? So overall, BigchainDB is a blockchain database. It's got these nice characteristics of databases, but then it also brings in these nice characteristics that blockchains have, like decentralization, immutability, and assets. So BigchainDB is, a database that has blockchain characteristics.
Yeah, say more about that. What are more of the differences between a database and a blockchain?
Yeah, so traditional databases, traditional ones are things like Oracle going back decades and decades, where there were these, tables, think of it like an Excel spreadsheet, but then they had querying on top so that you could make this special call using this special query language like SQL, and with that you could get from say 1 million or tens of millions of records, you could come back with 3 records or 20 records according to query. This person is over the age of 40, this person lives in Berlin, et cetera, and that was really nice because in one line you could specify, this detailed information, get back these records, and that's, sort of at a level for software developers and whatnot, but then that translates to immediate user benefits too at the higher level with the applications. And databases are really, what is storing all of our data out there. When you're using Gmail, when you're using Facebook, all of these things, at the core of what's storing your data is these databases. So they have a long, long history. And, they've continued to evolve over the years. And from the late 90s and throughout the 2000s, where they evolved was towards scalability. When you got to these applications as the web grew, these applications getting to 100 million and even 1 billion users, the databases, their ability to scale grew accordingly. And so to this day, they're out there, they're powering the internet, they're powering the web for all the data that is being stored. But one challenge that we've had is that it's typically one big organization, or you might have grown big, that can kind of controls all that data. So you've got a bunch of your personal data on Facebook, you've got a bunch of data with Gmail, all of this thing, right? And then along came Bitcoin, and it was really this sort of e-cash, right? The very first time that we could have this e-cash or e-gold that's out there, where the ledger of who owns what, remembering who owns what, was just kind of, no one owned or controlled that. It was just kind of out there because there was, thousands of nodes that were collectively storing that. And you can think of that as like a database, but it had this special characteristic that no one owned or controlled it, right? And that's really the very essence of, the idea of a blockchain. So under the hood, what Bitcoin had was this, thing that's called a blockchain technology, and at the core of that was this idea that no one owned or controlled it. The other couple of interesting characteristics was it was immutable. So once you write to it, it's like it's there for good, right? So it's like etching into stone. And traditional databases, I'll just go to the third characteristic. So the third one is once you have decentralized control, no single entity owns the controls, and once you have this idea of immutability, etching into stone, then you can start to have assets living on this thing. So with the case of Bitcoin, the asset is literally Bitcoins. And, these days there's, I think, $12 or $15 billion worth of Bitcoins out there. And, these started getting issued in the early days of Bitcoin, bit by bit, through this process called mining. And that's just happens to be how Bitcoin does it. But you don't have to stop at just, Bitcoins on the Bitcoin network. You can actually, if I want, I can declare that I'm issuing a set of assets onto some blockchain technology, and then I can transfer those assets to others and to others and others. So you can have basically this idea of, digital ownership. You own it if you have the private key, which is roughly like a password. So I can own a piece of digital art if I have the password. So these three characteristics taken together, decentralized, immutable, and assets, these are really the new things compared to the traditional databases that you see with, say, Oracle or Microsoft SQL Server, which is kind of the older school, and then these new scalable ones, such as MongoDB, which scale really, really well. So blockchains are databases with these sort of new characteristics. And what they compromised, though, in getting these new characteristics was the queryability and the scaling, right? So
well, let's talk about that now.
Information. Go ahead. Yeah.
Yeah, I was just about to ask you that. So what do blockchains lack that traditional databases have? It sounds like they're great. What's the downside?
Yeah, so the downside can be summarized as scalability and queryability, right? So, and part of the reason why was it's hard to get all things at once, right? And, so when Bitcoin came out, it was, it had enough new characteristics that made it interesting, right? But to achieve some of those characteristics, the way that, its engineering solution to achieve those characteristics was saying every single node needs to store all the data, right? And this is in database land, this is called fully replicated. But if every single node has to store all the data, then how can you have storage of, say, 10 terabytes, right? If I want to have a node, do I want to download 10 terabytes? That's going to, take a long time and cost a lot of money, right? So that was, whereas with traditional databases like MongoDB and stuff, the big data databases of the 2000s, their idea is that each node, each sort of physical machine only stores a fraction of the data, right? And you have backups and backups of backups, et cetera. But overall, no single node has to store all the data. So that was the one big challenge, and that sort of, affected capacity as well as, had side effects related to throughput and so on. The other aspect was this idea of queryability, right? So if you want to look at a set of all the transactions that I have recorded on Bitcoin, right? For myself to do that, I'm going to have to basically look at all the past transactions ever, and then see which lines up with certain public keys and so on, right? And addresses in general, Bitcoin addresses. So in order to do a query, I have to kind of look at all the previous items. Whereas with databases, they have for a long time they have querying sort of built in, and under the hood, it's been optimized for speed, where you can do lookups. Where you get log n scaling and so on. You don't have to look at everything all the time because you have pre-built these indices for looking certain things up. And so you can get, massive speed improvements. And that's why, let's say you're using Facebook and you type into the search at the top there, and it comes back with a result very quickly. Or Google, when you do a Google search, right? How is it possible where it gets its results so back even though there's potentially billions of records being looked at? Well, the answer is it's built these indices, right, that allow such that these queries can come back and return results very quickly. So that was the core thing, basically, was the blockchains didn't have the scalability in terms of capacity and otherwise. The other thing actually on scalability was throughput. It just basically there aren't that many transactions per second going through Bitcoin. So overall scalability, and then the second thing was the queryability. There really wasn't sort of queryability out of the box. And it's sort of a sign of that. There's these things called blockchain explorers where it's sort of a web page where you can go in and scroll across different transactions just to see what it is. And then if you want, there's typically a little search button in the top right that, not a button, sorry, a search box. You type something in, and then it has to look at all the past transactions, right? But that's exactly what databases do is, have this built-in querying. So.
All right, so what is, all right, so you really described well the difference between databases and blockchains and the advantages, disadvantages. So what's the goal of your company? How are you integrating the best of both to make something scalable and faster?
Yeah, so there's clearly differences between traditional databases and traditional blockchains, but our view is that, fundamentally blockchains, at least for most applications, are really databases. And that's been our philosophy, that's why we're called BigchainDB and not just Bigchain. And so the approach has been, okay, there has been a lot of efforts out there to try to scale up blockchains. And it reminded me of work that I did in the late 90s and throughout the 2000s, where I was working on AI systems, including distributed AI systems, where people, connected the dots. They figured out how to solve problem X or Y in terms of, just evolving something or doing AI of some form. And then they said, all we would need to do now is scale up. And it turns out that, when you scale up, you have to completely throw out all your previous algorithms and developments. And the only thing you really have to remember is the inputs and outputs. You kind of have to abandon your pet code. And this is kind of, when I saw all the efforts to sort of scale up blockchain, it reminded me of this. It's like, all we need to do now is scale up. And I was thinking to myself, well, that didn't work with AI, actually. It was actually a very different thing where typically you have to rethink the algorithms completely. And the algorithms you end up with tend to be much simpler. And there's been a lot of research showing this too, right? With every sort of 10x increase in data or other performance measures, you have a different algorithm that's better. So we have many friends in that were building infrastructure in the blockchain space, and we saw these efforts, and we thought that was really interesting and cool. But we had great needs. We had started off actually in mid-2013 doing a project called Ascribe. It's still online, ascribe.io, for IP on the blockchain and intellectual property on the blockchain, things like digital art, music, movies, all this sort of thing. And we were running into problems of scale there, right? And we were finding that we weren't able to serve our customers, people who were going through, say, 100,000 images a day. We simply couldn't put that onto the blockchain we had initially built on, the Bitcoin blockchain. At the time, it was going through 100,000 transactions a day itself. So if we actually turned on one customer, we would have doubled the number of transactions. And each transaction back then was custom content. So overall, we had this burning need, right? We weren't able to actually scale even ourselves to serve even one, larger customer. And so we were talking to, friends in the space, and none of them were actually building the solutions that were really in the near term. And we thought, okay, also what's out there, there clearly are things that scale out there. Facebook serving 1 billion users, many others doing 100 million plus users. Netflix was powering 37% of the bandwidth of the internet in the USA, running off of Cassandra instances, which is one of the big data databases. So there's clearly stuff that scales out there, right? And it's including databases. So we said, well, let's take one of these databases that's out there that clearly scales extremely well, one of these big data databases. And there's a lot, MongoDB, Cassandra are two great examples, and use that as a starting point, and then engineer in these deltas, the things that make blockchains interesting above and beyond traditional databases. And like I mentioned, those are three things: decentralized, as in no single entity owns or controls; immutable, like etching in stone; and assets. The idea that you can issue and transfer assets, and you own that asset the way that if you have the private key, basically. So we said, let's try this out. And we initially did a couple months worth of prototyping. This was in late summer of 2015. And it worked out remarkably well. We were kind of shocked how well it worked, actually. So we said, okay, let's put some more resources into this, because this could be a great solution to us, to even just for ourselves. And we saw also that others were having issues with scale too. So we started building that more and more and more. And in February of 2016, we got to the point where we could announce publicly what we were up to, and that's when we released version 0.1. And ever since then, we continue to iterate and refine. And what it was, version 0.1, it was open source software, remains like that. It's, of course, we released the white paper, the code, all of that. And ever since, we've released several versions. Now we're up to, we just released 0.8. And we're going to be doing 0.9 within the next few weeks here, and keep going. So what, yeah, I guess, go ahead.
So what does your solution do? I mean, first of all, which blockchain does it work with, or does it work with any blockchain, and what does it do?
Yeah, so it doesn't work with any blockchain because it incorporates the characteristics of blockchains itself into its structure. How we engineered it was we built on top of one of the one of the great databases out there that works. In our case, it was RethinkDB initially, which has really great scalability, really great querying, all of this. And more recently, we've been integrating into MongoDB as well, and that will be coming to a really full release very soon here, actually, which we're quite excited. So what does it do? In a sense, the interface is a mix of what you would expect from a traditional database, where you can create records and read them. Of course, you can't update them or delete them because that is not part of what blockchains do, right? It's really about creating records and and reading them. This is sort of the CRUD thing, just to be precise. And then, so it has an interface around that, which includes the querying and all that. And then there's an interface that is a bit more like you would expect from blockchain technologies, where it's issuing assets and transferring them. So basically, issuing an asset and transfer is really a create operation in database land. So I guess overall, from the perspective of if you're a software developer making, your next great blockchain application, then you're going to be doing a transaction, writing a transaction, which basically looks like some JSON code that is either a create an asset or transfer an asset. And you can get fancier too with fancier logic and stuff, but that's really the core. And then after that, the other thing is just simply querying to see, okay, I want to learn more about this asset here, or give me all the assets that meet this criteria, et cetera, et cetera. So at the end of the day, what does it do? Well, it acts like a database because it is a database that happens to have these blockchain characteristics, right? Once you've written, things are there for good, et cetera, et cetera.
What do you think is going to happen to existing blockchains out there, especially Bitcoin or Ethereum, or are they doomed just to be unable to scale, or what's going to happen?
So I'm pretty excited about a lot of the technologies that are out there, and my view overall is that there's really a stack. So I think blockchain as a noun isn't really an apt description of what's going on. It's sort of like, imagine we had vehicles, and everyone talks about, oh, is this vehicle doomed versus this one? Is this one going to take over? But once we ended up having cars and trucks and semis and motorcycles, then each one was, had its own pros and cons. So collectively they form all vehicles, but each one has its own benefits. So that's one example. But what's cool is they can also be used complementary to each other, right? So if you think about overall, the elements of computing, there's really three core elements, right? There is processing, there's storage, and there's communications. And this manifests in a sort of software stack that an application developer is building. They're going to want something that does processing. In a traditional system, that's, say, Amazon EC2. They're going to want storage. And in a traditional system, that comes down to two separate types of technologies. You've got file systems, whether it's, traditional Windows file system, or whether it's storing, blobs of data on Amazon S3 or something. And then you've got databases, right? So for storage, you've got file systems and databases. And databases are, these things where they have more structured data that you want to query to get, from a million possible results, you get 2 or 5 or 1 result, right? And that's like MongoDB or something. And then the third element, so we've got processing, we've got storage. The third element of computing is simply communication. And that's really just how the communication protocols interoperate with each other. So how does this map to the world of decentralization and blockchains? Well, there's actually some technologies out there that are really best suited to processing, decentralized processing. And these are things that are called smart contracts. And, smart contracts, everyone agrees, is not a great name because they're not terribly smart and they're not really contracts in a business sense. Decentralized processing is actually a much better fit because you basically got processing happening, like Amazon EC2 style or whatever, but it's actually happening in a decentralized fashion, where it's many, many servers at once, no single entity owns or controls, et cetera. Then besides that, you've got decentralized file systems happening, right? So instead of your Windows file system or Amazon S3 or something, you've got something decentralized, and that's something like IPFS, Interplanetary File System. That's just out there, right? And there's other ones too, lots of other really good projects out there for processing and for file systems. And then for us, it's really about a decentralized database, right? So processing, file system, database overall. And most of the people doing blockchain technologies are trying to do the smart contract stuff. So that's why we actually don't see that we have direct competition for people trying to do straight up just a database, right? So we're working on that. We're making it look, act, feel, right, like a traditional database, not trying to get fancy, just happening to have really great scalability in addition to these blockchain characteristics, scalability and queryability. So, and then to the question of Bitcoin, actually, it's really this sort of other category that's sort of an application level almost, and that's really Bitcoin is best thought of as an e-gold, electronic gold, a long-term store of value that, is independent of nations and so on, right? It also, depending who you ask, it also can be viewed as an e-cash, electronic cash, for more day-to-day sort of fast money type things. And so overall, as a value transfer mechanism, that's where, or store of value, that's where really Bitcoin is best suited. Whereas in something like Ethereum and many of the other sort of public blockchains, yes, they have a store of value, but that is simply a means to an end. In the case of Ethereum, it's really about decentralized processing. So we actually like to work very closely with, people in the space. The IPFS folks we work with closely. We work with many Ethereum folks closely. And, overall it's about, collectively building this whole decentralized stack together.
So how do you feel that you're going to play a role? Are you going to become the backbone or the blockchain of the database for, some new initiatives, new cryptocurrencies or other blockchains, or are you going to be in an advisory capacity? Hey, we can help you scale blockchain or Ethereum, or where do you see yourself fitting into the ecosystem?
Yeah, so overall, out there's a lot of people that are building applications that are only enabled now based on this new technology, right? Applications related to, for example, sovereign personal data, where you are owning and controlling your personal data rather than it being on these centralized servers. Or things like intellectual property, distribution of music and so on, right? This offers much better ways to connect the creator directly with the audiences, where the middleman has less of a role, and in some cases no role at all, right? And so there's people building these wonderful new applications in all these different verticals, and they're looking for decentralization technology to help them, right? In some cases, they're going to want decentralized processing. In other cases, file systems. In other cases, databases, right? Just like if you're an application developer building, the next Facebook or the next Netflix or whatever, you're going to use different technology pieces under the hood. So whenever they are sitting down and saying, hey, I need a database that stores this data, of who owns what, of different sorts of things, then that's where they would use us. So they would plug us in. Just like if you're, a traditional, web app developer or something, you might plug in MongoDB. Now, the decentralized is BigchainDB, right? So it's not about directly, helping people build better blockchains, because, that's not the point. It's this piece. It's a building block for the application developers, right? So they can plug in our database, right? And I guess related to this, though, is one funny thing about decentralization technology is you can view it as sort of a single system, a distributed system that has one administrator, and that's what distributed systems are. But in the case of decentralized, it means, no single entity owns the controls. So there could be 5 entities controlling it, or 50 or 500 or whatever. And, BigchainDB is no different that way. So that means, though, there's the software, but you also need sort of a network on top, right? That basically manifests the control by these 50 or 5,000 folks, right, or organizations. So we've been rolling out something complementary. So BigchainDB is the software, and IPDB is the network. And so people who are building applications on top, they can either have their own sort of private network, if you will, of 5 or 20 organizations, but they can also use this public network that we're rolling out called IPDB, and then they don't need to think about that. They can just plug into that. And we are very excited about that, because we see that it, along with some of these other emerging technologies, are new pieces of internet infrastructure. If everything goes according to sort of our visions and hopes, right? Just like sort of right now, the DNS is something that's out there. When you type in, say, Amazon.com, it goes to a particular IP address, say 123.456.789. And that's sort of this database that helps to power the internet for this one very specific thing, right? But what about, a database of who has created what song, or who has created what image, right? Or a whole bunch of other things, right? There is no sort of piece of internet infrastructure that's out there for the sort of public commons, if you will, this commons database of who owns what for these various verticals, whether it's intellectual property or otherwise. And this is kind of what we see that we're helping to roll out. So this is what IPDB is. It's this public network powered by BigchainDB software for now. And it really is exciting to us, so that's how people would use us. If you're a developer, it feels like you're using a hosted solution, just like hosted MongoDB, or which is called Atlas, or some other hosted solution. But in this case, it's not hosted by just one party, but a whole bunch of parties that are collectively running it together, right?
So what are some simple use cases of your software, of your database, and how would they look differently from how they look now? Then let's take music.
Yeah, so for sure, that's a great start, and that's an exciting one. So I'll give an example with one of the organizations that we were working with called Resonate Co-op. They're based in Berlin, and they have the vision of a decentralized streaming service. So they are a co-op, so it's not a company, but a co-op where you can spend $5 or more and get one share in the co-op, and then you can have hundreds or thousands of owners overall in this co-op. And so that's sort of the ownership. But then in terms of the user experience, as an artist, if I was a musician, I'm not a musician. I'd be a terrible musician. But if I was, I could register my work on Resonate, claim copyright, very likely claim it with others. Maybe there's a different songwriter versus the performer, and maybe multiple performers, etc. And that's all written down onto this planetary database, IPDB, that's powered by BigchainDB. And then it's just that kind of out there, right, being stored. And I've made that claim of that song, and I've registered the song. It's all there. And then someone else comes along, say you, and you want to actually listen to this, right? So you basically can browse and discover the song, and then you can start listening. And you paid a fee of, say, I don't know what the pricing will be, but the other streaming services are on the order of $8 a month. So you pay a fee, and then you listen, and then basically it gets calculated how much goes back to that initial artist, that initial musician, say myself, right? And so that just happens immediately or very quickly, versus right now when this stuff gets paid, it could be 3 months, 6 months, even 12 months, because the loop is very slowly closing. It's a slow loop through collecting societies, et cetera. And also the musicians end up not getting a lot, right? A number I saw recently was when a song gets played on YouTube, 1/8 of a cent is collected by Google, and then the performers only get a fraction of that, of course, right? But I'm getting much more than 1/8 of a cent of utility by listening to that song, right? So there's a lot more opportunity here for sort of coming up with new organizations of how to connect the musicians, the creators, and the performers with the listeners. And it can be done in a way where, multiple things can be done on top very quickly, experimenting. Right now, something like Spotify, they have the database, they have all the licenses they have with the different platforms, et cetera. But it's really hard for others to build things on top of their platform to explore new ways for musicians to get compensated, et cetera, right? So this helps to unlock that benefit. And overall, too, with music, another example related is in the world of digital art, where we started with the question actually in 2013, how do you collect digital art, right? If I'm an artist and I make an animated GIF or a video, what is it that I sell to the collector, right? Do I sell them just, this physical DVD artifact? What if that gets scratched, right? And it turns out, this is really about, licensing of IP. And but then who stores the license of who owns what, right? It's really best suited to be in this sort of planetary register of who owns what, who is licensed what, et cetera. And, that's really what drives us. So that's another example in the IP space. There's some other verticals. I mentioned before, sovereign personal data, where, I am controlling my data, and I'm choosing who has access to what. And IPDB can be a big piece of helping to implement that. And we're working with several companies on that front as well.
How come all these applications haven't come out before? How come, for instance, music, why is it that you have to have these big platform companies, YouTube, Spotify, et cetera, that get the music out to everyone? How come it can't happen your way?
So I think actually it comes down to actually sort of an advance in database technology, as well as an advance in the understanding of how to apply some of the technologies that has existed for a long time. So Bitcoin sparked that, right? Bitcoin was the very first time that we had an electronic money that was a ledger, powered by a ledger, this sort of database that no one owned or controlled. People had tried to do the electronic money in the 90s, probably most famously DigiCash out of Amsterdam, but it failed because it was centralized largely, and also some other reasons, but really the main challenge was the centralization. And there was a few attempts here and there throughout the 2000s. And when Bitcoin finally came out, 2009, 2010, this is really what it sparked this whole, new wave of thinking, because Bitcoin really worked and works well, right? And, it sort of demonstrated this model, but, why stop at just sort of digital money? Why not about who has created what song and who has created what photograph and all of that, right? And the technologies below too, Bitcoin actually had some new ways to look at how to look at database technology. In database land, there's these traditional ideas of things like cap theorem, the sort of trade-off between consistency and availability in the face of partitioning. I won't get into it, but overall, Bitcoin had a completely different take on it, which basically added this economic constraint. So people weren't as motivated to cause a partition because if they did, they'd lose a bunch of their Bitcoins, this sort of thing. So it was actually a computer science advance as well. And because it sparked so much awareness, it's a really cool technology, then a lot of people that weren't traditionally in the database space started thinking about it a lot more, and we've seen some other really cool advances since as well. So there's this whole, new wave of computer science that's emerging in the decentralization space, and that's helping to power, these new ideas. And same thing with the music rights to your question. People had thought about it before, but more from a more centralized standpoint. The music labels even tried getting together several years ago to have their own shared database among themselves called the GRD, and it failed largely because of sort of politics. They couldn't figure out well enough, how do we share this, who controls it? But what if there was a way where no single entity could control it, and each label really had just a fraction in a really nice way, all the way down to the fundamentals of the database control itself. And this is kind of what it enables, right? So it enables these sort of consortiums, if you will, the big labels and others, or, tens of nodes, hundreds of nodes, thousands of nodes. The technology was only really possible now, and it unlocks all these applications about, sharing of databases. Once you have immutability, then you can have these new things and assets, right? Another example on the asset side is, think about when you do a Google image search, right? And you you see all these images show up, and maybe you find an image you like, but you can't find out who owns it, right? How do you license it? So you probably right-click copy, and some people right-click copy and hope for the best that they don't get sued. Other people just restrict the search to Creative Commons because where it's okay to use it as long as you give attribution, and that's cool, right? Or maybe you just do a search within Getty, but that's a super small set of images. But imagine though, because there's all these different silos of who owns what, right? 10 million images here, 10 million images there, and so on. But if there was some sort of database that was out there that wasn't controlled by any single entity that easily anyone could plug into, then it completely changes the picture. So now instead of right-click copy, you have right-click license, right? And once again, it's only possible now. And so all these new applications are only possible thanks to the technology developments sparked by Bitcoin.
It's funny when you were talking about the music industry, how they wanted to do something like this, but they couldn't decide who would control it, and there was fighting, I guess. I was about to ask you, what's to stop governments or big consortiums or, from taking all your technology but just centralizing it, but having the same method of allowing people to license or, have assets, et cetera. And it's funny, it comes down to the control, who has control, and people don't want centralized control of things. They want to really control it themselves or have it fair and equitable. It seems like that's the one thing that would make this work.
Yeah, so certainly, the technology, you could have a consortium of a smaller number of entities. And, my fundamental hope is that most of this, whenever it can be public and shared among thousands of nodes, tens of thousands, millions, it's so much better, right? It's just better for society overall. Within information technology, there has been traditionally a bias to centralize, right? We've seen that, going back 150 years, from the telegraph to the telephone to radio to TV to the internet, the World Wide Web, and so on, right? And, probably, and every single one has become decentralized at least at one point in time, and most of them has become centralized. At least one point in time, and most of them have stayed that way. Sometimes they have waves in and out of centralization and decentralization, but there's this bias towards centralization. And, we've seen it most recently with the centralization of the web, right? if you think about the visions of the mid-90s to what we have now, now we have, these giant powerful players with, 500 million or 1 billion users each. And that's where most users spend most of their time. And it's actually quite sad. So it had this natural centralizing tendency. But, and also with governments too, they haven't been as quick on centralization, but of course they want to, they have a tendency to want to have power and so on, which is actually interesting in the sense of it's kind of against the idea of a democracy, at least the traditional idea, where one vote, one person. But of course,
Right.
once you have representatives in the middle, then there's risk of centralization there, et cetera. So my view is, with any technology, when you're building it, you have to think about the values that you're building against, like the values that you have, and you are imposing values whether you mean to or not. So you better mean to, because otherwise you get the values wrong, right? And so I think it's actually quite exciting. People in the decentralization space, especially those who've been around the block for a while, they're thinking about this a lot. They're saying, what can I do to help, make sure that this really happens in a public sense rather than just, consortiums of 3 or 5 super powerful companies, right? Or if it is 3 or 5 super powerful companies controlling some piece to start with, then how do I make it such that over time it could decentralize more and more so that it's not just controlled by 3 or 5, but then 10 and then 20 and then 50, right? So these are questions we ask ourselves all the time. This is partly why, we've been building IPDB with PublicNet that's just really easy to deploy, on top of, et cetera. And it's actually got thought-out governance from day one, right? So we have very explicit rules for things like protocol changes and so on, right? And this matters. So, technology has values embedded in it. You better design for them up front, and that includes the governance part too. I come from the AI world, and obviously, that has a lot of implications too. And there's a growing number of people in AI thinking about this. But people have been thinking about this for a long time, right? Even in the mid-90s when I started working on AI, people were thinking about it. It's more and more, and decentralization even more so. Yeah, stop there.
Any dangers to decentralization, especially as it intersects with AI, or just with the nature of people?
Actually, yeah. So that's a more sharp question than you might realize in the sense of danger. And maybe it's obvious from a 10,000-foot perspective, but it's certainly a challenge actually. So there's a lot of ways that it's possible interplays between AI and decentralization technology. I spent almost 20 years in AI. I've spent several years in decentralization. When I was doing AI, I was also doing distributed systems. So thought about a lot of those. I've thought a lot about both. I've actually written about the link between them in several essays online on Medium, actually. And the biggest danger actually is what I call AI DAOs. So DAO, as in Decentralized Autonomous Organization.
Right.
And overall, I'll define this a bit more, but overall, what decentralization offers is AIs that, AIs that can actually own themselves and accumulate wealth, right? And they don't even need to be very smart. They can be AIs in today's kind of, narrow, naive sense of the word. It doesn't need to be some sort of crazy sci-fi thing of waking up at all, right? And I'll describe why this is a bit worrisome. So actually, first though, I'll describe a bit of this idea of DAO, Decentralized Autonomous Organization, and actually full credit to the Ethereum folks for really elaborating on this to start with a couple of years ago now, more than that. So if you think out there about like a computer virus, right? Someone writes it and just puts it out there, and it kind of copies itself and makes it, thousands or even millions of copies throughout the world, right? And that's actually, it's kind of amazing that a piece of software can do that for starters, right? You wouldn't think so, but it just kind of does. And this is, some people have argued that they're sort of like life forms, and there's an argument to be made. There's maybe a checklist of 15 or 20 criteria of what it means to be life, and a computer virus actually hits many of those checks in the checklist. But then imagine if you have, overall you can think of it as code that you can't turn off, right? But it's also code that you can't really control that well, or it can't even accumulate wealth very well, right? But imagine, you put this out into some, decentralized processing substrate. That it's code that's running, and I maybe to start with, I can control it by my private keys, like my passwords, and so it's running, which is pretty cool. And it's sort of like, it's not a virus, but instead it's doing something else. Maybe if this and that sort of functionality. If it monitors the weather, and if at 7 o'clock in the morning it sees that it's raining and sends me a text message, hey Trent, you better put on your raincoat today, right? But there's obviously fancier applications, things like software as a service, but more sort of decentralized, if you will. There's a lot. I can get into that. But overall then, once you sort of pull the plug of not having control by me, it just sort of lives on its own, then that's called a decentralized autonomous organization, or DAO, right? And it's this thing that just sort of lives out there, does its own thing. And the amazing thing is it can accumulate wealth, right? You can send it money, it can hold it, because it can actually have a Bitcoin wallet or an Ethereum wallet or something, right? And but imagine now in this processing that it's running on this, decentralized processing substrate, it doesn't have to be just simple if-thens, but it can start to be technologies from the AI world that have better decision-making. So things like, classical simple neural networks to today's more modern deep learning neural networks, or and these, can be simple classifiers or regression, things like automated fraud detection and so on. But then they can also be sort of more agent-like, where they're kind of running, taking in inputs, updating the state, returning outputs, and then even learning over time and updating their state in sort of a more full-fledged fashion. And my simple example is, I call it an art DAO, where there's AI technology that can generate art, right? It's been around for 15, 20 years, even more. But it could generate that art, it could register it, and then it could start selling it. So it'll sell, 10 limited editions for, say, $10 each. So it makes $100. And maybe it only costed $10 worth of computing to generate that art to start with. So with that $100, it creates 10 new pieces, sells each of them for $10 each. So that is 10 times 10 times 10, so $1,000 that it makes, right? And then so with each sort of iteration, it goes from owning $100 to $1,000 to $10,000 and so on, right? And you can make it so you can't pull the plug, right? Unless you have some sort of hard fork, or people really pull. I won't go into that, and that won't even be possible in some systems coming down the pipe. So overall, then here we have this robot out there that is you can't turn off, that's selling art, creating new art, and accumulating wealth, right? It could be the world's first AI millionaire, or even, dare we say it, billionaire, right?
Mm-hmm.
And yeah, I should say, so why is this worrisome? Well, what if it starts mining code from GitHub, for example, right? And people start putting stuff that's more malicious. Or it could adapt on its own, too, using things like genetic programming, where I spend a lot of time. So it's not necessarily a static thing. And that's where things get interesting, but also dangerous. And, the reason I wrote about this is because we need to start talking about this now, so that we can actually come up with reasonable solutions that where we don't accidentally, give too much control of our assets to AIs and accidentally lose control of them ourselves, right? Self-driving cars are coming down the pipe. What about self-owning cars, right? Where cars can
I was going to ask you about that. Well, what would be the danger of a self-owning car or a self-owning art-creating AI DAO?
Well, the art-creating AI DAO, I think that's not so dangerous, right? Because it's only creating art, and if people stop buying, that's fine. So, but what's good about it is that it can help to raise the conversation to the next level. Prod conversation towards things like self-owning cars and self-owning trucks and self-owning grids, and then collections of these that are optimizing at higher and higher levels, right? And so, and it's really basically the danger overall is that we give control of more and more of our resources as humans, of more of our capital, and the AIs end up controlling a lot more capital. And depending who you ask, if you don't control capital, you can't control anything at all. Then, right? It's capital leads to more capital, leads to more capital. And there is motivation for things like self-owning cars, right? You've got Uber. They're moving to self-driving cars because then, their profit margins go up, and it helps to, guarantee they have a more sustainable business or whatever. But then the motivation to go to self-owning would be to be capital light, right? Just like, many years ago, BMW, they stopped owning factories and all of this, and instead just focused on the design part and went capital light for the rest, to really focus on their core competency. If Uber goes with self-driving cars, are they going to buy all of them themselves? That's a huge capital outlay compared to the capital they have laid out so far, right? So maybe they do a leasing program with humans or whatever, but another possibility is actually a leasing program with robots, right? And so that might, might be the direction they go, so to be capital light. But it's not just Uber. I mean, if you think about, lots of companies are trying to go the BMW route of being capital light, and self-owning is a path to it, right? There's other incentives there.
What would be the point of a self-owning car besides making just enough for it to exist? I mean, what's the point of it accumulating capital? What's it going to do with it?
Well, maybe, once it gets near the end of its life cycle, then it, who knows, actually, right? That it has all this wealth. Maybe it just knows that it's going to die after 25 years, and that's it, right? An example of something where you want self-owning where there's benefit in the longer term is there's a project here in Berlin called Terra Zero, which is a self-owning forest, actually. And, if you think about forests, they don't just last for one human lifetime. They last for generations and generations, right? It might take 100 years for a tree to grow or longer, right? So here you have this DAO that's running for a longer period of time where it can accumulate wealth and basically guarantee that that forest is maintained over time, independent of different political regimes every 4 years or different lifetimes. It's just this thing that's running itself, right? And we have this, prototypical versions of this in the form of trust funds and in some cases even corporations and so on, right? But they're often also partly at the whim of, day-to-day decisions by the CEOs of the boards. But if you can actually make it more independent of that, there could be a lot of value to society, right? So there's good in this too, right? Like the self-owning stuff could have a lot of, benefit to society, like I described, right? And it's a whole new set of questions. And, the reason we have to be talking about this stuff now because the technology is coming down the pipe a lot sooner than we realize, than people might realize. The sort of intersection of AI and decentralization. We're not there yet, right? There's lots of the pieces, but the next, 1, 2, 3, 4 years, there's going to be massive changes, right? And it's mostly exciting, but there are dangers, and this comes back to the values thing too that we were talking about even before the AI stuff, right? You have to be building, you have to be thinking about what are the things that you value. Do you care about humanity in the long term versus short-term gains and stuff, right? And, this is what drives us every day. We see that we can help to create some new pieces of internet infrastructure and in a way that can benefit society in the long term, right? And we're trying our hardest to avoid getting captured by dollars, by dollar interest, by jurisdictions, et cetera, right? And we're not going to claim that we have the best design yet, but we have to keep the conversation going and keep improving upon that.
All right. Well, I'm sorry to take you off on this, this side talk, but it seems like you have a lot to say about this and about the, about blockchains and databases. I mean, you have too many talents.
No, I think it's important. No problem. Yeah.
Yeah. All right. Well, we'll finish up. What's the best way for people, companies that are interested in BigchainDB to get information about what you do, to get your help on, helping them set up these databases that you set up, the decentralized ones? What do they do? What's the best way for them to reach you?
Yeah, so BigchainDB.com is where you'll, the main landing page for the company, and from that there's a quick start button, front and center. So if you're a developer, go there. And then to develop against it, as you'll see, you can run your own local node and develop against that. And then at some point, you can either run IPDB network, run on that, or run your own network privately, in a small group or larger group. And so IPDB, to learn more about that, go to ipdb.foundation. So it's a German nonprofit foundation. And those are the two main ways for learning about BigchainDB and IPDB. Also, for myself, if you want, email me. I'm Trent at BigchainDB.com.
Okay, well, very good. I appreciated the interview went in a lot of interesting directions. There's a lot more here, so yeah, I appreciate your time, sir.
My pleasure. Thank you very much.
You have been listening to Almost Here, Around the Corner of Future Technology podcast with Richard Jacobs. Subscribe to this podcast, post a review to discover more future technologies that are poised to transform our lives for better or worse, such as Bitcoin, artificial intelligence, 3D printing, blockchain, virtual reality, and more.
So things like, classical simple neural networks to today's more modern deep learning neural networks, or and these, can be simple classifiers or regression, things like automated fraud detection and so on. But then they can also be sort of more agent-like, where they're kind of running, taking in inputs, updating the state, returning outputs, and then even learning over time and updating their state in sort of a more full-fledged fashion. And my simple example is I call it an art DAO, where there's AI technology that can generate art, right? It's been around for 15, 20 years, even more. But it could generate that art, it could register it, and then it could start selling it. So it'll sell, 10 limited editions for, say, $10 each. So it makes $100. And maybe it only costed $10 worth of computing to generate that art to start with. So with that $100, it creates 10 new pieces, sells each of them for $10 each. So that is 10 times 10 times 10, or $1,000 that it makes, right? And then so with each sort of iteration, it goes from owning $100 to $1,000 to $10,000 and so on, right? And you can make it so you can't pull the plug, right? Unless you have some sort of hard fork or, people really pull. I won't go into that. And that won't even be possible in, some systems coming down the pipe. So overall then, here we have this, robot out there that is, you can't turn off, that's selling art, creating new art, and accumulating wealth, right? It could be the world's first AI millionaire, or even, dare we say it, billionaire, right?
Mm-hmm.
And yeah, I should say, so why is this worrisome? Well, what if it starts mining code from GitHub, for example, right? And people start putting stuff that's more malicious. Or it could adapt on its own, too, using things like genetic programming, where I spend a lot of time. So it's not necessarily a static thing. And that's where things get interesting, but also dangerous. And, the reason I wrote about this is because we need to start talking about this now so that we can actually come up with reasonable solutions that where we don't accidentally, give too much control of our assets to AIs and accidentally lose control of them ourselves, right? Self-driving cars are coming down the pipe. What about self-owning cars, right? Where cars can
I was going to ask you about that. Well, what would be the danger of a self-owning car or a self-owning art-creating AI DAO?
Well, the art-creating AI DAO, I think that's not so dangerous, right? Because it's only creating art, and if people stop buying, that's fine. So, but what's good about it is that it can help to raise the conversation to the next level. Prod conversation towards things like self-owning cars and self-owning trucks and self-owning grids, and then collections of these that are optimizing at higher and higher levels, right? And so, and it's really basically the danger overall is that we give control of more and more of our resources as humans, of more of our capital, and the AIs end up controlling a lot more capital. And depending who you ask, if you don't control capital, you can't control anything at all. Then, right? It's capital leads to more capital, and there is motivation for things like self-owning cars, right? You've got Uber. They're moving to self-driving cars because then, their profit margins go up and it helps to, guarantee they have a more sustainable business or whatever. But then the motivation to go to self-owning would be to be capital light, right? Just like, many years ago, BMW, they stopped owning factories and all of this, and instead just focused on the design part and went capital light for the rest to really focus on their core competency. If Uber goes with self-driving cars, are they going to buy all of them themselves? That's a huge capital outlay compared to the capital they have laid out so far, right? So maybe they do a leasing program with humans or whatever, but another possibility is actually a leasing program with robots, right? And so that might be the direction they go, so to be capital light. But it's not just Uber. I mean, if you think about, lots of companies are trying to go the BMW route of being capital light, and self-owning is a path to it, right?
There's what would be the point of what would be the point of a self-owning car besides making just enough for it to exist? I mean, what's the point of it accumulating capital? What's it going to do with it?
Well, maybe once it gets near the end of its life cycle, then it who knows actually, right? That it has all this wealth. Maybe it just knows that it's going to die after 25 years, and that's it, right? An example of something where you want self-owning, where there's benefit in the longer term, is there's a project here in Berlin called Terra Zero, which is a self-owning forest, actually. And if you think about forests, they don't just last for one human lifetime. They last for generations and generations, right? It might take 100 years for a tree to grow, or longer, right? So here you have this DAO that's running for a longer period of time, where it can accumulate wealth and basically guarantee that that forest is maintained over time. Independent of different political regimes every 4 years or different lifetimes. It's just this thing that's running itself, right? And we have this, prototypical versions of this in the form of trust funds and in some cases even corporations and so on, right? But they're often also partly at the whim of, day-to-day decisions by the CEOs or the boards. But if you can actually make it more independent of that, there could be a lot of value to society, right? So there's good in this too, right? Like the self-owning stuff could have a lot of, benefit to society, like I described, right? And it's a whole new set of questions. And, the reason we have to be talking about this stuff now because the technology is coming down the pipe a lot sooner than we realize, than people might realize. The sort of intersection of AI and decentralization. We're not there yet, right? There's lots of the pieces, but the next, 1, 2, 3, 4 years, there's going to be massive changes, right? And it's mostly exciting, but there are dangers, and this comes back to the values thing too that we were talking about even before the AI stuff, right? You have to be building, you have to be thinking about what are the things that you value. Do you care about humanity in the long term versus short-term gains and stuff, right? And this is what drives us every day. We see that we can help to create some new pieces of internet infrastructure and in a way that can benefit society in the long term, right? And we're trying our hardest to avoid getting captured by dollars, by dollar interest, by jurisdictions, et cetera, right? And we're not going to claim that we have the best design yet, but we have to keep the conversation going and keep improving upon that.
All right, well, I'm sorry to take you off on this, this side talk, but, it seems like you have a lot to say about this and about the about blockchains and databases. I mean, you have too many talents.
No, I think it's important. So no problem. Yeah.
Yeah. All right. Well, we'll finish up. What's the best way for people, companies that are interested in BigchainDB to get information about what you do, to get your help on, helping them set up these databases that you set up, the decentralized ones? What do they do? What's the best way for them to reach you?
Yeah, so BigchainDB.com is where you'll, the main landing page for the company. And from that, there's a quick start button, front and center. So if you're a developer, go there. And then to develop against it, as you'll see, you can, run your own local node and develop against that. And then at some point, you can either run IPDB network, run on that, or run your own network privately, in a small group or larger group. And so IPDB, to learn more about that, go to ipdb.foundation. So it's a German nonprofit foundation. And those are the two main ways for learning about BigchainDB and IPDB. Also, for myself, if you want, email me. I'm Trent at BigchainDB.com.
Okay, well, very good. I appreciated the interview went in a lot of interesting directions. There's a lot more here, so I appreciate your time, sir.
My pleasure. Thank you very much.
You have been listening to Almost Here, Around the Corner Future Technology podcast with Richard Jacobs. Subscribe to this podcast, post a review to discover more future technologies that are poised to transform our lives for better or worse, such as Bitcoin, artificial intelligence, 3D printing, blockchain, virtual reality, and more.
You get information about what you do, to get your help on, helping them set up these databases that you set up, the decentralized ones. What do they do? What's the best way for them to reach you?
Yeah, so BigchainDB.com is where the main landing page for the company, and from that there's a quick start button, front and center. So if you're a developer, go there, and then to develop against it, as you'll see, you can run your own local node and develop against that, and then at some point you can either run IPDB network, run on that, or run your own network privately, in a small group or larger group. And so IPDB, to learn more about that, go to ipdb.foundation. So it's a German nonprofit foundation. And those are the two main ways for learning about BigchainDB and IPDB. Also, for myself, if you want, email me. I'm Trent at BigchainDB.com.
Okay, well, very good. I appreciated the interview went in a lot of interesting directions. There's a lot more here, so I appreciate your time, sir.
My pleasure. Thank you very much.
You have been listening to Almost Here, Around the Corner Future Technology podcast with Richard Jacobs. Subscribe to this podcast, post a review to discover more future technologies that are poised to transform our lives for better or worse, such as Bitcoin, artificial intelligence, 3D printing, blockchain, virtual reality, and more. Subscribe to this podcast, post a review to discover more future technologies that are poised to transform our lives for better or worse, such as Bitcoin, artificial intelligence, 3D printing, blockchain, virtual reality, and more.